So we're going to be talking about the basics of probability today. Something that's very crucial to statistics is figuring out probabilities and reasonable guesses and whatnot to kind of help guide decisions. And so, in general, probability basically comes down to the single basic fraction of the following. It's the number of ways you want stuff to happen. Let me make this a little bit bigger here. So the number of ways you want stuff to happen over the number ah the number of ways stuff can happen. And that's, again, that's just basically the gist of probabilities. If you can get those two values, then you've gotten your probability essentially. So we can put a little bigger fraction bar there to make it look a little bit more reasonable. There we go. So this fraction here is basically what we're trying to get at each time we're doing a probability problem. How many ways can we get something to happen that we want versus how many ways can something happen in total given a situation. Now the problem is that when you have more advanced problems, these numbers become more difficult to get. Like if you have a case where there's a lot of different ways things can go and a lot of different repetitions of things as well, that can get kind of hard to calculate. And so we've developed methods and stuff to deal with that. But today we're just going to kind of focus on the basics of, okay, what if we get in some small sort of problems to get our feet wet essentially. So let's start with the smallest of ways is kind of the very, very, very basics of probability that we can probably just review here real quick. So the probability of getting a prime number on a normal six-sided die. Well, we have 1, 2, 3, 4, 5, 6 on a six-sided die. So the number of ways things can happen is 6, right? We have 6 possible numbers we could roll here. Well, how many of them are prime? Well, 1 is not prime. It's a special case, remember. 2 is prime, 3 is prime, 4 is not, 5 is prime, 6 is not. So we have 3 ways that we want to have happen, and 6 ways that stuff can happen. So 3 primes that we want, 6 numbers that total can be rolled. So that would be end up with a probability of 1/2 or 0.5 or 50%. All three of those mean the same thing. Usually in stats we try to stick with the decimal form, but either one is acceptable by me. So again, number of ways we want stuff to happen, number of ways things can happen in a given situation. The chance of picking an ace from a 52 card deck. So 52 card deck implies that there are 52 cards. So we have 52 cards. And if you want to pull an ace, for those that don't know the makeup of a card deck, there are 4 types of aces in a deck. You have an ace of spades, you have an ace of hearts, you have an ace of diamonds, and you have an ace of clubs. So there's 4 different kinds of aces you could pull. So it'd be 4 out of 15, or sorry, out of 52, which would end up reducing down to 1 out of 13 as the probability. And again, you can make this into a decimal or and a percent if you want to. But again, 4 ways that we want to have happen, 52 ways that stuff can happen. So that's your end goal, remember, is to get how many different ways can you get something to happen versus how many different ways can something happen. In a class of 8 boys and 11 girls, what's the chance of picking a boy if you pick a student at random? So in this case, many people would make the mistake and go 8 out of 11 because they say, okay, 8 boys, 11 girls, they just use both numbers. The problem with that is that this is not representing the number of ways things you want to have happen versus the number of ways things can happen, because this is the number of boys you can pick. So that number is right. The number of things we want to have happen. Well, there's 8 possible things that are boys that we want. Well, on the bottom, this is not the total number of ways things can happen, though. We could pick one of the 11 girls, or we could also pick one of the 8 boys as well, because remember, this is total, not just the things you don't want, but everything total. So right here, we're going to put a 19 instead of an 11, because there's 19 total people we could pick from. 8 boys that you want, or that you could pick, out of 19 students total if you're picking somebody at random. So again, don't be too quick in writing down your fraction. Make sure you look at your fraction and say, okay, did I actually put the total number of things on bottom, or did I skip something that I need to account for? Because again, this, if you go too quickly, this can get you really quickly. So those are the basics of probability in terms of, like, the bare minimum problems. Let's step up here a little bit next and talk about complements. So the complement of an event, or the complement probability, is basically a chance that it does not happen. So if I say, let's say event A represents the flipping a heads. Actually, no, we'll say rolling Let me just do this. Let me type it out here, given my handwriting. Let's just say A represents rolling a 3 or 5, either one. So A represents rolling a 3 or 5. So the probability of A, so the probability of rolling a 3 or a 5 is a 2 out of 6. So the probability of the complement of A, which we write down as A bar, so this means complement of A. Now again, it can be kind of confusing because before we represented bar as being average, like X bar was the average of something. Capital A bar is the complement of the event A. The main reason you can tell the difference is because the A is capital. So usually if something's capital, it's kind of changing stuff around a little bit. So A bar represents the complement of A, which if there's a 2 out of 6 chance of getting a 3 or 5, that means there's a 4 out of 6 chance of not getting a 3 or a 5. So this would be 1 out of 3. This would be 2 out of 3. Again, that's what they mean by complement, because if I add these together, I should get 3 out of 3, which is 1, or 100%. Which again makes sense, because if you take the chance that something does not happen and add it to the chance that something does happen, well, that's your entire sample there. One of those things is going to happen. An event is either going to happen or is not going to happen. Like if I say the sun is going to come up tomorrow, well, I'm either going to be right or wrong. The sun's either going to come up or it's not going to come up. There's no middle ground there. So that's where we get this idea of the complement being 1 minus the probability of the original event. So here, if I do 1 minus 2/6, I get 4/6 based on my example up here. So once again, the reason this is true, the reason this probability holds is because if you have if you have a situation, at its core, there's basically two outcomes. It's either going to happen or it's not. So you can use the complement to kind of help you in that regard. Now, why would we bother figuring out the complement? Well, it happens that the reason we focus on finding the complement, or the reason that we have this in here, is that sometimes, especially when we get to the bigger stuff down the road, it's easier to find the chance that something does not happen rather than the chance that something does happen. And again, we'll get to those problems a little bit later on, but just kind of keep in the back of your head here that the reason we have this complement theorem or this complement property here is the fact that if I want to get the chance that something does happen, it's often easier for big situations to get the chance that something does not happen and then just find the complement. And again, that's the approach we'll take quite a few times with certain situations. But that's what we mean by when we say the complement of the event. The complement of the event is the chance that it does not happen. And it's equal to 1 minus the chance that it does happen. So again, they have that relationship. And lastly, we're going to talk about odds here. So the odds of a situation are not quite the same as probability. Probability associates itself with, if you remember, there it is. So probability is equal to ways something can happen out of, or I should say it this way, the way I use the same lingo. So number of things you want over number of total things that can happen. That's what probability is. So let me make that a little bit bold here. So probability is the number of things you want over the total number of things that can happen. Odds are a bit different. Odds are, well, there's actually three of them. So let's talk about odds against, because it's usually one of the more common ones here. So odds against is actually using the probability. It's the probability that something does not happen, or put another way, the complement, right? So the probability of the complement over the probability of the event. So the chance that something does not happen divided by the chance that something does happen. So it's not the same as probability because it's using probability in order to define it. Now, to put it another way, it's the number of things you don't want to the number of things you actually want, that you do want. And notice how it's a slight difference between probability here. Probability is the number of things you want over total. Odds, in either form, do not have total in them. So odds do not concern themselves with the total number of outcomes. They're always split between things you want and things you don't. So if I, for example, said the following, let's say odds against rolling a 6. We'll say on a standard 6-sided die. Okay? Odds against rolling a 6. Well, there's 5 ways I cannot get a 6 and 1 way I can. So the odds against rolling a 6 is 5 to 1, or 5 out of 1. Usually it's written as a colon, so 5 to 1. That's usually how it's said. The odds in favor is simply the reverse. The chance that something does happen divided by its complement, or the chance that something does not. And again, this is often written using the complement notation. So we'll say A over A complement. So they'll usually write it with the complement notation rather than just saying not A. And again, this is just the reverse of the odds against. So again, this holds the same sort of relation. So odds in favor of rolling a 6 would just be the reverse of the odds against. So it'd be 1 way of getting a 6, 5 ways of not. So again, that's where we get the number of things you want over the number of things you don't want. 1 6 that I want, 5 non-6s that are there. Not the same as probability, although you could make this into a decimal, because you could just, whoops, my bad, wrong one. 1, 2, 5. You could just divide this out and get a decimal, which again represents a few other things that we'll go over. But in general, it's usually written as this to that. They're usually left in this form here. So again, similar to probability, but not quite the same because they don't involve the total amount of stuff that can happen. The payoff odds is specifically for gambling and betting, and it's basically the amount of money you could win on a bet divided by the amount of money you would have to bet to win that. And again, net profit means your winnings minus your bet. So if you bet 20 bucks and you get $5, that means your net profit is 5, and the amount that you bet is 20. Or sorry, the amount that you bet was 20, right? So if you bet if you bet 25 and you earn 30, then your net profit is 5. And so your payoff odds against, again, this is payoff odds against is how it's usually said, is the amount of money you could win over the amount of money you'd have to bet. So that would be your payoff odds against, which would be 1 to 5. Again, keeping with this notation here. Now, this is often used as casinos to kind of judge how good a game is and how much they should devote to promoting it, because casinos use this idea to kind of evaluate whether they should keep certain games or change the rules or change the betting procedures, so they're always making money. They actually make sure that their games do not have the payoff odds and the actual odds against being the same. So the payoff odds against and the actual odds against should not be the same for a casino, because if they were the same, then all they would do is break even. So if you have the payoff odds equaling the actual odds against, what you have is what's called a fair game, and a fair game means that on average, over the long run, neither person's going to win or lose. They're both going to come out with the same amount of money that they entered in with over, again, an average amount, a large average amount of games. And that means that the casino would just be breaking even on their game, and they wouldn't be making money. They'd actually probably be losing money because they have to pay people to actually run the game and employees and all that. So they want to make sure that their payoff odds are not equal to their actual odds against. So let's look at a quick game that's usually played in casinos and kind of see how they would judge that there. So we'll take a look at roulette here. Roulette wheel is basically a wheel with 38 numbers on it of equal spacing. So if you haven't seen one, I'll try to do a quick little diagram right here. So here's a wheel. You have an equal spaced slices all the way around, and each of these slices have numbers on them from 0 to 36. And then they have a double zero as well, so a total of 38 numbers. Each one occurs once, and they're alternating between red and black. So you have red, black, red, black, red, black. So you can bet on both colors and numbers and a combination of such. But we're just going to focus on the numbers right now. So again, from, we'll say double zero all the way to the last one, which would be 36. Okay? So double zero all the way to 36, and we want the chance of rolling a 13. Okay, so the probability, first thing we talked about, let me try that again. The probability of rolling a 13 is simply, again, how many things you want to happen over a total number of things that can happen. Well, the chance of us rolling a 13, there's one 13 on the roulette wheel because no number repeats. And as we just said, there are 38 total numbers on the roulette wheel. So my probability of rolling a 13 is 1 out of 38. That's the probability. 113 out of 38 possible numbers, and that can't be reduced anymore. By the way, the complement of this, so I'll write, again, A here. So the complement of this event, if we call that this event is A, the complement of that would be 37 out of 38. Because remember, it's 1 minus this. So 1 minus 1/38 is 37/38. So this is the chance of not rolling lucky number 13, which is a pun there in case you're not picking up on it. So probability, complement, first thing we talked about, very closely related. Now we're going to get to the odds here. So the odds in favor of rolling a 13. So remember, the odds in favor represent numbers that you want to have compared to numbers that you don't. So if we look back here, number of things you want compared to number of things you don't. So the odds in favor of rolling a 13. Well, how many 13s are there? How many numbers do I want? Well, there's one 13 on there, like before. Okay, how many numbers are not 13? Well, if there's 38 numbers and one of them is 13, that means there's 37 that are not. So the odds in favor of rolling a 13 are 1 out of 37. Okay. So this is what they usually call a 1 in 37 chance, although it's not quite the same, even though people misuse that lingo when they're talking about odds. But the odds in favor of you rolling a 13 are 1 to 37, a 1 to 37 odds. The odds against would just be the flip form, right? 37 numbers we don't want compared to the one number we do. So the odds against rolling a 13 is 37 to 1. Or again, that's how I'd say it. Again, 37 in 1 really doesn't make sense. So again, people try to use that lingo, but it doesn't really represent what's actually going on there. So usually you want to stick to saying 2. So 37 to 1, 1 to 37. Don't say a 1 in 37 chance, because actually it's a 1 in 38 chance that you're going to do it. That's more probability, even though people get these two mixed up. Now, the payoff odds are the other tricky one here, right? So let's say you bet $5, and the payoff odds are 35 to 1. So that's what the payoff odds, that's what the casino is saying for your bet there. So you have to first figure out, okay, what does this mean here, 35 to 1? Well, that means that if we look here, 35 to 1, what does the payoff odds mean if we go back here? So payoff odds are the net profit of winning, 2. Again, I only won't say divide, I'll just say 2. So net profit of winning to the amount of money bet. So this is the winnings to the amount of money that you bet. So what that means here, if we put this in language terms, is if you bet $1, and win, you earn $35. Whoops. Again, net. So it's not that you come out with $34. You earn $35 as a net profit, not 35 minus 1. That's already taken into account with the odds there. So for every $1 you bet, you win 35. So that would be another way of putting it. For every $1 bet, you win 35 if you win. I got it's a little redundant there, but if you win, you earn $35 for every $1 that you bet. So if you bet $2, you get 70. If you bet $3, you'd get 105, so on and so forth. So that's how you think about payoff odds, is the amount of money you earn for the amount of money you bet. $35 for every $1. So how much money would you make if you rolled a 13? And again, let's say you're betting $5 here. So you're betting $5 and you roll a 13. Well, the payoff odds we said are 35 to 1. So if I bet $5, how much money would I make? Well, if we do some proportion math here, so I'm betting 5 times more than 1, so my winnings should be 5 times more than 35 because I'm betting 5 times as much. So if we do some quick math, 35 times 5, come on, 35 times 5, we get 175. So if you bet $5, you would make $175, which means the casino would actually pay you $180. But again, that net profit is what we're going for there. So you make a net profit of $175 as you make. So notice how the phrasing here is very important. How much money would you make, not how much money would you get. So you would get $180 back, which would be your $5 plus your winnings of 175. So usually we're only concerned about how much money you actually net profited, because that's what makes the difference there. So if I said how much money you would make if you roll a 13 and you bet $12, again, times 12 times 12. So if you have a $1 bet, it's really easy to get your odds for other money because you just times the winnings by however much more you're betting. If this was something like, just a side example here, let's say you're playing another game and the payoff odds were 8 to 3, and they said, okay, what if you bet and won off of a $9 bet? They need to say, okay, if I bet and won off of a $9 bet, that means that it'd be 3 times 3, which would give me 9. So 8 times 3 would give me 24. So I would make $24 off of a $9 bet. So usually payoff odds are given as something to 1. Usually this number right here is a 1 because, again, that makes people have an easier time figuring out how much money they want to bet. But you can do it without it being a 1 by just doing some math and searching around and whatnot. So this is kind of an unusual way of saying your payoff odds, but just in case it does happen, just think about, okay, if this is how much money I bet, what's the multiplier I would use here, and use that same multiplier on your winnings. So if the payoff odds were the same as the odds against, what would that mean in terms of money made / bet? How much would you make if you could bet $5 with those odds? So it says if the payoff odds were the same as the odds against, which we just said the odds against were 37 to 1. So if the odds against are 37 to 1, and I bet $5, again, that's times 5, that means I would make 37 times 5 times 5 gives me 185 times 5. So I would make $185 off of a $5 bet if the payoff odds were the same as the odds against, because the odds against are a little bit higher because it's a little bit more rare to roll a 13 than a 35 to 1. It's actually a 37 to 1. So how does the casino know it's going to make money? Well, that's because they're actually paying you $175 for a win, when given the chance of actually getting a win, they should be paying you 185 if they're being fair about it. Because the chance of you rolling a 13 is so small that every time you bet $1, you should be earning a little bit more in order to be a fair game to represent the chance of rolling it being that small. But the casino is actually shorting you $10, theoretically speaking, so that even when you win, the casino doesn't take a complete hit. So that way, on the average, again, think about hundreds and thousands and millions of games played. On the average, not only are they making money each time somebody loses, but they're losing less money each time somebody wins. So in the end, they actually come out ahead because they make more money from the people losing and they pay less money to the people winning. So the subtraction there of money that they pay versus money that they earn always stays in the positive for them because essentially, quote unquote, they're shorting you your actual earnings by making the payoff odds less than the odds against. Think about like in the extremes essentially. What if the payoff odds were 2 to 1? Well, that'd be a very poor payoff odds, right? Because the chance of you rolling a 13, or the odds against rolling a 13 are 37 to 1. So there's 37 numbers that you don't want and one number that you do. But they're only going to pay you $2 for every $1 you bet. Which again, if you bet $5, that means you're only going to be making $10. So again, could you make money off this? Yeah. But given your odds against, this would be a very poor payoff odds and probably nobody would play it. So casinos, that's what they do. That's what their statisticians and mathematicians do, is they figure out, okay, how low, how skewed can we make the payoff odds so that people still feel like they should play the game, but that we still end up ahead even when we have a few number of people that actually end up winning. So again, if you make the payoff odds too low, nobody plays because they feel it's a scam. If you make the payoff odds too high and they become the same as the odds against, then you're either breaking even or losing money. And then again, you have to find that sweet spot there where people are willing to risk, but they actually don't end up ahead even if they win, at least compared to you. Because again, the casino really doesn't thrive off of a single game. It thrives off of multiple games. It plays what we call the average of large numbers. Over a large amount of time, you're going to have more people losing a game than winning. So if you can make money off the people losing, and then for the people winning, if you can pay them a little bit less than what's representative of the risk they're taking, you can always end up ahead. Again, as long as you're smart about things. So that's it for this one. Again, just a quick recap of the basics of probability, and then we'll kind of expand on this later on in the week. Hope this video helped you out. Have a good day.